Next, properties of dot product. The first property is I dot I cap, j cap dot j cap, k cap dot k cap. What will be the output? Here, I cap dot I cap, which means magnitude of I into magnitude of I and cos 0. Why 0? I cap is nothing but unit vector in the direction of x-axis. Here, both I cap are in the direction of x-axis. So the angle between them will be 0 degrees. So from here you can write it as 1 because this is the unit vector, so the magnitude will be 1. Similarly, j cap dot j cap, again magnitude of j multiplied with magnitude of j, again cos 0 because both are in same direction and gives 1. Similarly, k cap dot k cap is nothing but 1. So here the output will be 1. Next, I cap dot j cap, j cap dot k cap, and k cap dot I cap. What do you guys think the output might be? See, when you multiply I cap dot j cap, which is nothing but magnitude of I cap multiplied with magnitude of j cap and cos 90. Why 90? I is nothing but the unit vector in the direction of x-axis. J cap is nothing but the unit vector in the direction of y-axis. So x and y-axis are perpendicular to each other. So the angle will be 90 degrees. What is cos 90? It is 0. Similarly, j cap dot k cap will be 0 because y and z vectors are perpendicular to each other and z and I, sorry, z and x-axis are also perpendicular to each other. The output will be 0 here. And what is a vector dot a vector, which means magnitude of a multiplied with magnitude of a. Again, these two are same vectors, so it becomes cos 0. So the output will be magnitude a square. And a dot b is equal to b dot a, which tells us that these two vectors are commutative to each other. Why? Because dot products, because I already told you that when you multiply two vectors using a dot operator, you will get the output as a scalar quantity. So this so when you multiply either a dot b or b dot a, they are equal because there is nothing to do with the direction over here. Next, a dot b plus c. So here we can distribute the a for these two vectors. So dot product is a distributive. Next, L times of A vector dot product with M times of B vector. As L and M are the constants, we can take it out. So as L multiplied with M gives a number and remaining is A dot B. The last property is A vector multiplied with null vector is a null value, that is 0. Why this dot product is that much important? This is important because it helps to find the angle between two vectors. A remark over here is if two vectors are given in the Cartesian form, which means A vector is given in this way and B vector is given in this way. And what becomes the A dot B. It's nothing but just multiply the coefficients of I cap. That is A1 B1. I cap dot I cap I already discussed in the properties, that is 1 plus A2 B2 plus A3 B3. What about the cos theta? Cos theta is nothing but dot product divided by its magnitude. So A dot B is nothing but, we have already got the value, that is A1 B1 plus A2 B2 plus A3 B3. So what about the magnitude of A vector? That is nothing but का coefficient square, that is A1 square plus A2 square plus A3 square, and B vector, similarly, it's the under root square of its coefficients, that is B1 square plus B2 square plus B3 square. The same thing we'll write over here, and you'll get the cos theta value. Now let's see few remarks over here. First is, as cos theta is positive over here, the angle will be a acute angle. Here, A dot B is less than 0, which is nothing but cos theta is negative. So the angle will be obtuse angle. Next, A dot B is equal to 0. It means cos theta is 0, which is nothing but two vectors are perpendicular to each other. So the angle over here will be 90 degrees. Now, next thing is A plus B whole square. Now, how to find this value? We can write it as A plus B dot product with A plus B. Now, when you split it, you'll get it as A vector dot A vector plus A dot B plus B dot A plus B dot B. I already told you A dot A is nothing but magnitude of A square, and here A dot B and B dot A are commutative. So we can write it as 2 times of A dot B and plus magnitude of B square. So this is the formula you can remember for A plus B whole square in vectors. So similarly, it goes with A plus B plus C whole square. The final pro the final result, you will get it in this way, that is magnitude of A square plus magnitude of B square plus magnitude of C square plus 2 times of A dot B plus B dot C plus C dot A. You can also derive this similar to this A plus B whole square derivation. You will get this result.